Nexpera produces both sulfur trioxide and oleum. Liquid SO3 is produced by condensing purified SO3 vapors distilled from oleum. Oleum is also known as fuming sulfuric acid. It's a solution consisting of SO3 in 100% sulfuric acid. Nexpera offers this high-quality chemical in strengths ranging from 20% to 65% oleum. SO3 and oleum may be delivered by portable tanks, tank trucks, or rail cars, depending on customers' needs. Though SO3 and oleum are useful, they can be harmful if safety practices are not followed during handling. It's important to know about their unique characteristics and potential hazards before you work with these volatile chemicals. SO3 and oleum are hazy off-white liquids. They weigh about twice as much as water and give off visible fumes of sulfuric acid mist when SO3 vapors combine with atmospheric moisture. The amount of fumes increases as the oleum strength or the amount of SO3 present increases. 20% oleum, which is 20% SO3 by weight, and 80% sulfuric acid, has a low vapor pressure and gives off a relatively small amount of fumes. 65% oleum and SO3, which have the highest vapor pressures, produce the most fumes. Even a small liquid spill can result in a significant fume release. Oleum and SO3 give off visible fumes of sulfuric acid mist that can cause irritation and even serious injury to the nose, throat, and lungs. All grades of oleum and SO3 will freeze. Oleum may freeze during shipment or use, but will fall readily when gently warmed to a temperature that is 20 degrees Fahrenheit above its freezing point. SO3 is extremely temperature sensitive, and climate control is a major issue during its handling. To better understand the unique properties of SO3, let's first look at water. It boils at 212 degrees Fahrenheit and freezes at 32 degrees Fahrenheit. SO3, on the other hand, boils and freezes at a much narrower range. It boils at 112 degrees Fahrenheit and freezes at 90 degrees Fahrenheit. This is why it's so important to keep SO3 in the workable control range of 95 to 105 degrees Fahrenheit. Frozen SO3 can exist in three forms: gamma, beta, and alpha. SO3 maintained in the liquid state will contain only the desirable gamma form. However, moisture and temperatures below 90.5 degrees Fahrenheit can convert SO3 into less desirable beta and alpha forms. These higher melting point solids are more difficult to melt. Alpha melts at 144 degrees Fahrenheit, which is above SO3's boiling point of 112.6 degrees Fahrenheit. When heated, it vaporizes instead of melts. All three forms of SO3 can exist at the same time. It's very important to keep the temperatures between 95 and 105 degrees Fahrenheit to avoid both freezing and boiling. Nexpera offers a stabilized grade with an inhibitor to retard formation of the high melting point solids. This makes it possible to more readily remelt frozen SO3. Customers have a choice between stabilized and unstabilized SO3. In either case, thawing SO3 is a very time-consuming and painstaking procedure, so it's best to keep it from freezing in the first place. Both oleum and SO3 react violently with water, creating intense heat and giving off large quantities of fumes. Oleum and SO3 both react violently with concentrated alkali. They both react with cyanides and sulfides to generate poisonous gases, while reactions with carbonates such as soda ash create carbon dioxide, which can cause suffocation. When diluted with water into sulfuric acid, oleum and SO3 are corrosive to many metals. They give off hydrogen gas, which can accumulate to form explosive mixtures. Even though oleum and SO3 don't burn by themselves, the hydrogen they release is dangerous. Sparks or open flames around oleum and SO3 storage tanks or any metal equipment could ignite the hydrogen and cause fires or explosions. SO3 and oleum are very reactive and can even cause fires when they come into contact with certain combustible materials. SO3 and oleum also absorb moisture while giving off heat. If SO3 or oleum touches an unprotected body, they can cause immediate and serious damage. Look at how quickly the acid burns this chicken leg. Not only would they burn your skin, but they could also damage vital organs and cause death. If you get SO3 or oleum in your eyes, they could cause permanent damage and blindness.